video, we will look at converting areas and volumes. This is a place where many students make very understandable mistakes. Let's suppose we know that 1 yard is equal to 3 feet. Does that mean that 1 square yard is equal to 3 square feet? So I'll put a question mark above this one to indicate we're trying to figure that out. And the answer is no. That is not correct. Let's make a drawing to understand why. Imagine we have this square that is 1 yard by 1 yard. Since 1 yard is 3 feet, this also means that this thing is 3 feet by 3 feet. Now let's find the area. 3 feet times 3 feet is equal to 9 square feet, not 3 square feet. This happens because area is two-dimensional. When we convert lengths in both directions, the scale factor gets applied twice. Now let's do a more realistic example. Let's suppose we have an 800 square foot room. And we want to know how big this is in square meters. We begin with a lengthy conversion. We do know that 1 foot is 12 inches. We know that 1 inch is 2.54 centimeters. And we know that 100 centimeters is equal to 1 meter. So let's slowly convert this. 1 foot, I put feet on the bottom and inches on the top. We have 12 inches in 1 foot. Then we put inches on the bottom and centimeters on the top. 1 inch is 2.54 centimeters. We then put centimeters on the bottom and meters on the top. We have 1 meter is 100 centimeters. And we can work this out. When we do, we get that this is about 0.3048 meters. And that's for a single foot. But we're actually converting square feet, not just feet. So 1 square foot is going to be about 3.3048 meters times 0.3048 meters, 1 for each dimension. This tells us that 1 square foot is about 0.0929 square meters. So to invert 800 square feet, we put our square feet on the bottom, our square meters on the top. 1 square foot is 0.0929 square meters. When we work this out, we get about 74.32 square meters. So we had to do a little bit more conversion. We started with feet, then we had to square that conversion to get to feet to meters squared, square feet to square meters. We can then use this conversion factor. Now let's repeat the idea for volume. Let's suppose we want to convert 13 cubic feet to cubic meters. We're going to use the same base length conversion that we already found. We already discovered that 1 foot is 0.3048 meters. But this is cubic feet. So 1 cubic foot is 0.3048 meters cubed. We basically just cube both sides of this equation. This is about 0.02832 cubic meters. We then have 13 cubic feet. We want our feet unit to cancel, so that goes on the denominator, whereas cubic meters goes on the top. 1 cubic foot is 0.02832 cubic meters. When we multiply this, we get about 0.368 cubic meters. This is such an important idea. Length conversions use the factor once. Area conversions use the factor squared. Volume conversions use the factor cubed. This is why drawings and models are so helpful. Students can often memorize a rule like square it or cube it, but a picture helps them understand why. As a future teacher, that understanding will help you explain this clearly and respond to student misconceptions with confidence. You have now worked through the big ideas of measurement units, conversions, reasoning with conversion context, dimensional analysis, and area and volume conversions. These are rich topics, and it is completely okay if they take time to settle in. The goal is not speed. The goal is sense-making, and you are absolutely capable of doing that.